Hey Trig class, this is our first section in chapter 4, and we're going to be in all of chapter 4, we're going to be graphing all of our trig functions that we have studied about. And the first ones that we come to are the sine and cosine functions. With the class activity that we have just completed, we should know what a sine and a cosine function looks like, and we'll be building on top of that with what we learn in this section. So we're going to be learning about graphs of sine functions and graphs of cosine functions, and then some graphing techniques and something called the amplitude and period of your sine and cosine functions. And then that's about it. So let's go ahead and get started. Sine and cosine functions and other trig functions are called periodic functions. It's because they repeat themselves over and over in a pattern. So here's a couple of things that are predictable and repeat many times. So things in daily life that repeat with a predictable pattern are things such as weather, tides, and hours of daylight. And then this right here is a graph of that represents a normal heartbeat. So we can call that a periodic pattern right there. Okay, so let's look at more on sine and cosine graphs and functions. We have learned in class already that the circumference of the unit circle is 2 pi. So the least possible value of p for which the sine and cosine functions repeat is 2 pi. So p represents the period of the function. So that's what we're going to call that. And therefore, the sine and cosine functions are periodic functions with period 2 pi. And these following statements right here are true. And n represents just an integer, so 1, 2, 3, even negative values, 0, -1, -2. Okay, so this right here, sine of x, is equal to sine of x plus any integer times 2 pi. So whenever we add any multiple of 2 pi, as we've learned, that is a coterminal angle. And coterminal angle values in trig functions are the same. They are equal to each other. So whenever we graph sine of x and something that is sine of x with the added multiple of 2 pi, we are going to get the same graph. They're going to overlap each other. Same thing goes with the cosine graph. Okay, so more on values of sine and cosine functions. As s increases from these values, this is what happens to our sine of s values. And s represents the angle, okay? And these are angles that we are plugging in. So as s goes from 0 to 2 pi, so from down here on this little sketch that I've done, this is 0. This is going to be, sorry, I said 2 pi, I meant pi over 2. This is pi. 3 pi over 2 and 2 pi. Okay, so as our sketch of our graph goes from 0 to pi over 2, our graph is increasing, so it's going up. And then from pi over 2 to pi, it decreases, and then it keeps decreasing from pi to 3 pi over 2, and then it goes back to increasing. And it's going to repeat that pattern over and over. We're going to, so another period of our function is going to have that same exact pattern. And it's going to keep on doing that in both negative direction and positive x direction. Now, the cosine function, it does the same pattern except it's shifted compared to our sine function. So as our values of s go from 0 to pi over 2, it decreases. So you can see that in red here, that it decreases from 0 to pi over 2, and then keeps decreasing from pi over 2 to pi, and it goes back to increasing. So it increases from pi to 3 pi over 2, and then increases again from 3 pi over 2 to 2 pi. So that's the predictability of sine and cosine functions right there. So here's another thing that we learned in that activity, that the domain of a sine function and cosine function is all real numbers, and the range of sine of x is from -1 to 1. And this is what our graph looks like. And as I've said before, it just keeps on going in both directions. Whenever we go to graph these sine and cosine functions, these are the x values, and then along with the y values that we are going to be graphing. The rest of it doesn't matter as much, but we are going to plot these points on our graph. And this is because this is where it's going to cross the x-axis for one of them. This is going to be our maximum, and then across the x-axis again, our minimum, and then it crosses the x-axis again. And whenever we have those points, we can draw a smooth curve, a smooth wave through all of those 5 points. And then that will be our sketch of our sine function. Same goes whenever we sketch our cosine function. We have a domain here, all real numbers, again, range, same thing as the sine function. And whenever we go to sketch our cosine functions, again, we're going to be using the same x values to plug in and find the y values for. And these particular x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi, that represents one full period right there, those 5 values, and you will get a maximum, an x-intercept, a minimum, and another x-intercept, and then your maximum again. And that will represent this portion of your graph right here, one full period of your cosine function. Okay, we're going to be graphing this function right here and compare it to the graph of y equals sine of x. I'm going to go ahead and graph in y equals sine of x. Here I just graphed one full period, and this is y equals sine of x right there. And how this graph compares, this is the function that we have, y equals a times sine of x. And notice we have our value of a is 1/2. This value right here is known as how we find the amplitude. The amplitude, or a in this case, is always going to be the absolute value of whatever this value of a is. So just 1/2 in this case. So if it's negative, your amplitude is going to be positive still. So if this was negative 1/2, your amplitude is 1/2 still. Okay, this amplitude is actually going to help you in graphing this function. Get another pen. And the reason that this is going to help you graph your function is this sine graph before, our value of a was 1. And so our amplitude is 1, meaning the highest value that you have on your sine graph is 1, and your lowest value you have on your graph is -1. So the only way this value of a changes our sine graphs is by either stretching that value up more or shrinking it down. And in this case, since it's 1/2, it shrinks it down to 1/2. So instead of having amplitude or value for our maximum and minimums to be 1 and -1, it's going to be 1/2 and -1/2. So nothing changes about this sine graph right here, sine of 1/2, or 1/2 sine of x, except these values here are here, and this one is here. And the rest of the x values is still going to cross the x-axis at the same x-intercepts. So now, with these 5 points, we can go ahead and draw, that's terrible, let's see, draw let me try that again. A curve through all of those points right there. So that is our graph of this y equals 1/2 sine of x. So amplitude, how I told you to find the amplitude is it's that value of A, and you're going to say, I'm going to use capital A as the value for your amplitude. You're going to say that is equal to the absolute value of that A value. Okay? And otherwise, this is how they explain amplitude. It's half the difference between the maximum and minimum values. And it's always going to be that right there. And then again on amplitude, as I explained in the first example there, that whenever you have sine A times your sine of x or A times cosine of x, your range is going to change to whatever that value of A is, just like this right here. Instead of our range for sine of x and cosine of x being -1 to 1, because our value of A is 1, it changes whenever this value of A changes. Okay, something else that we need to point out about sine and cosine graphs, it says no matter what the value of the amplitude is, the periods of y equals a sine of x and y equals a cosine of x are still 2 pi. So let's consider this now, a graph that looks like this. Okay, so whenever we plug in values of 2x into our function, it stays, we're not going to get anything different on amplitude in our x-intercepts. What does change is the period of our function. And how we identify the period of our function comes from this value right here, which is our value of b. So whenever you write it out as sine bx, say a times sine, this value right here that is multiplied to x is known as our b, and how we get the period of our function, it is always going to be 2 pi over b. So for this particular function here, we're going to say 2 pi over pi, so the period of this function is pi. And that is going to help us in graphing our functions, knowing what the period of our function is equal to. Okay, so in this example, let's go ahead and say, well, our amplitude is equal to the absolute value of 1, so it's just 1. And our period, let's go ahead and identify that. The period of our function is 2 pi over b, and this time our value of b is 1/3. And that is going to give us, remember, multiply the numerator by the reciprocal of the denominator is how you do fractions here. 2 pi times 3 over 1, which equals 6 pi. Okay, on this one right here, our period is 6 pi, meaning one full period goes from 0, so starting here, to 6 pi. So I'm going to do this. I'm going to say we're going to have the same thing. We're going to have a maximum here, a minimum, or another x value, x-intercept here, a minimum here, and then here. One full sine wave here at this point represents 6 pi. Now, whenever you go to graph all of these sine and cosine functions that we're graphing in this section, you need to label all of your x values for your maximums and minimums and your x-intercepts. So how you're going to do this is, okay, since this is one full period at 6 pi, now split this up into quarters to find the other x values. So 1/4 of your period is going to be this value right here. So to get your first x value is going to be, well, first x value is 0. And then the second one is going to be 1/4 times your period, which is 6 pi. Your third is going to be 1/2 of your period. And then your fourth is going to be, let's see, 3/4 times your period. And then your one full period is 6 pi. 1 times that. Okay, simplify all of these right here to get 0. And let's see, that's 3/2. And that gives you 3. And let's see, this will be 9 pi/2 and then 6 pi. So these right here, these 5 values represent your x values that you need to label on your graph for one full period. This is 3 pi/2, and that's 3 pi, and this is 9 pi/2. And now just draw your sine wave through all of those maximums and minimums and x-intercepts. And we are done. So that's graphing one full period. So what changes from comparing this graph to this one right here, one full period for this function right here is 2 pi. This one here ended up being 6 pi. All right, so let's graph a cosine function with our value of b being 1/2. And our amplitude in this one, again, is 1. So the highest and lowest values can be 1 and -1. And our period of our function is equal to 2 pi over b, which is 1/2. So that is equal to 4 pi. Now let's go ahead and find all of our x-intercepts and our x values for our highest and lowest values. So just like a sine and cosine graph, start with 0, and then for the first x value, it's 1/4 of your period. Then second one, 1/2 of your period. 3/4, and then 1 times 4 pi. Okay, reduce it, so you get 0 pi, 2 pi, 3 pi, and 4 pi. Easy enough. So that is what I'm going to label my x-axis with, is pi, 2 pi, 3 pi, and 4 pi. 4 pi will represent 1 full period. And remember, cosine function will begin at 0. On the sine function, it begins at the origin, 0, 0, if you want to start at doing 1 full period of that. But for a cosine graph, cosine of 0 is 1. So there's our first value. Cosine of pi is going to be 0. Cosine of 2 pi, it's going to end up being -1. Cosine of 3 pi, this here. And then our cosine function of this value here is 4 pi, back up at 1. Okay, so now let's connect all of these values. Terrible curve there. Okay, let's do that again. I lost my point down here. There. I am much better at this on paper than I am on this tablet. Okay, so there is your 1 full period of a cosine function. And this is often how it is going to look. Instead of like a wave going up and then a wave going back down and back up, you're going to have going down and then back up, and you're done. So here are the steps that I've been going through. I think your book has pretty much the same steps here as I've been doing. To graph either a sine or a cosine function that has a different value of a, and then has a value of b being multiplied to x. First step is, what I do is find the amplitude and find your period. And then divide your period into intervals of 4 equal parts, like I did, and multiply your period by 1/4, 1/2, 3/4. Then you're done with that. And then at each value of your divided 4 equal parts of your x values that you found, evaluate either your cosine function or your sine function, whatever you have there, at each of those x values, and plot those points. And then draw a smooth curve through each of those points. And if you need to draw additional periods, then keep on going with the same exact pattern. Okay, so let's do this one real quick. We have amplitude, absolute value of 3, so it's 3. So the highest and lowest values are 3 and -3. And then our period of our function is going to be 2 pi over our value of b is 2. So we get pi. And here, my x values that I'm going to plot on my x-axis are going to be 0, 1/4 times pi, so pi over 4, and then pi over 2, 1/2 times pi, and then 3/4 times pi, so 3 pi over 4, and then pi. And those are going to be your 4 x values here. Let's see, pi over 4, pi over 2, 3 pi over 4, not 2, and then pi. Now evaluate each of these x values by plugging it in for x here into your sine function. And what you're going to get is, I'm going to say 0 for the first one, then -3 for the pi over 4, then 0 again for pi over 2. Y'all can plug this into your calculator, and I can show you a quick and easy way of getting all of these values. Just remind me to do that tomorrow. There. And then back down at 0. And so there you go. I went ahead and graphed it for you while it was paused, but there it is. There's the graph of your sine function with amplitude 3 here, and all of your x values appropriately named on here, and that is one full period. As you can see, it goes one full revolution right there to pi. So something you saw in the last example that I just did is this right here. It says when a is negative, the graph of a or a sine bx or a cosine bx is a reflection across the x-axis. So if we go back to this, instead of our sine wave going up and down and then back up, it started going down and up and then back down. So it's been reflected across the x-axis. Okay, let's look at this one real quick. Here we have an amplitude of absolute value of 2, so 2, and a period of 2 pi over pi over 2. Okay, what happens here is we get this. Our pi's end up canceling, and we get 4. Whenever we have a multiple of pi inside our cosine or sine functions, we actually will end up numbering our x-axis here with integer numbers. So one full period is 4. I'm going to start at 0. 1/4 of 4, 1. 1/4 of 4, 1/2 of 4, 2, and 3, 4. And that's what we're going to be numbering our x-axis with. 1, 2, 3, 4. Okay, and then draw your cosine function with amplitude of 2. So right here, I'm going to name that 2, -2. And remember, cosine function starts at 1, 0, 1. So our first value is here. Next one here. And we have a minimum here. Back up the x-axis and then back up at the highest point here. Oops. There. Now connect a smooth curve. So there you go. That's what it should look like right there. Cosine graph with x values 1, 2, 3, 4 for your period. One full period. The last example I have for you, you are actually given the graph of a function and then asked to determine the equation from the graph. So how we're going to do this is we're going to look at it and, well, determine the amplitude. This right here is 1/2 and then -1/2. So amplitude is 1/2. So our value of a in our function, either a sine or cosine function, is going to be 1/2. And then determine at this point, is it going to be sine or cosine? Well, if it goes through the origin, it's a sine graph. If it starts up here and as a maximum or a minimum, it's going to be a cosine graph. So if it starts here or down here, we're going to have a cosine graph. And then, so far we have y equals 1/2 sine. Now we need to figure out our value of b. And how we figure out our value of b, here is one full period right here at pi. And to get our value of b, just like how we get our period, just work your way backwards. So I've said here's kind of the formula here. Period of our function is equal to 2 pi over b. So our period is just pi equals 2 pi over b. Solve that for b. You actually end up getting b is equal to 2. So on this function that we are coming up with, it is going to be 2x. And that is it on this one. So I am done with this lesson. Hopefully y'all learned a little bit of how to graph sine and cosine functions, and we will practice that in class when I see you next. Goodbye, everybody.